Okay, what we are going to do now is we are going to work on using the distributive property to get rid of the parentheses in order to isolate our variable. You can do new page, you can do continuing. We are going to be using the distributive property to get rid of the parentheses in order to isolate our variable. Get your notes out. What? I don't know. Shh. Okay. In this problem, if you go through our steps, step 1 we've talked about is combining like terms. Are we going to have to combine like terms on this one? No, we're not. So then we go to isolate the variable. Now when we've isolated the variable, we've identified what operations are happening. And what operations are happening in this problem? Okay. What operations do we see up here? There's 2 operations happening. What operations are they? Sophie? Yeah. No. Kaya, sorry. I was thinking Sophie looking at you. There's multiplication and subtraction. However, our multiplication is being done in a different way. What is different about the multiplication operation in this problem compared to the last problem we did?
It doesn't show the symbol or have it next to the variable. It's because there's nothing between the parentheses, remember?
Right. And what else is different? You are multiplying this entire quantity of b minus 4 negatively twice. Okay? You are multiplying that entire quantity by 2 to the negative. There are 2 ways to think about it. One way to think about it is you are essentially saying, and that's kind of b minus 4, so a negative b minus 4 plus a negative b minus 4. You're adding those 2 things together. So when you do that, you have negative b plus 4 plus negative b plus 4. Then you would combine your like terms, and there's a whole process over here to do this. Can you see where I'm going with this? Okay. This is the long way. But you have learned the distributive property, so you can avoid doing all of that. How do we apply the distributive property to this problem? What would I do?
You would, negative 2
times 4 times negative 4. Okay, I'm going to keep that as a negative 4. Okay, my next part is going to be writing this out, and I would rewrite it as negative 2 times b plus negative 2 times negative 4. Now you could do it this way. You could subtract negative 2 times 4. You could do it either way. If you're going to look at this as a subtraction problem, your 4 over here needs to be positive. If you're looking at it as an addition problem, your 4 over there needs to be negative. So I'm going to go with negative 2 times b plus negative 2 times negative 4. Okay? What's my next step? So I'm applying the distributive property in order to get rid of the parentheses so I can isolate my variable. What is going to be my next step in here with the distributive property? We did a whole worksheet on this. Cole, what's the next step? Right, my next step is to do what's inside the parentheses. This is when I'm applying PEMDAS. So remember in our directions when step 2 was isolate the variable using PEMDAS? That's this. So I'm going to have negative 2b plus negative 2 times negative 4 is 8 equals 12. And now we're down to a problem that you should recognize. It's a basic 2-step equation. And from this point on, you should be able to solve it fairly easily, right? Yeah. So I'm applying the distributive property in order to get it to the easiest possible way I can solve it. Yes? Yes, which is exactly the same as that. If you subtract a negative, you add. If you did it the other way, so you must have done it the other way, you would have negative 2b minus negative 8. It would just look like that. And that's the exact same problem. Okay, yes? Got it? Gotta do this again. Yes, we're going to stop there because I'm assuming you know how to do it from here. So, step 1 after this would be what? Oh, you're doing it the other way. Okay, hold on to that way. What doing the distributive property would you do? Shh. Okay, next step would be doing what? You have to perform the operations within the parentheses because of PEMDAS. You're getting rid of those parentheses. 3 times k is 3k. 3 times 8, 24 equals 21. Now what? What's next? That's a 1. I'm not going to divide yet because when I'm undoing this to isolate, what do I do first? Addition, subtraction, or multiplication, division? So do I have addition in this problem? I want to undo that first. So what will I do first? 24. That gives me 3k equals negative 3. And then I do by 3, just a regular 3. Because k equals negative 1. Now here's what you need to remember. The part you do not want negative is the variable. You want a positive variable. What the variable equals, it doesn't matter if it's positive or negative. That's not important. This side can be negative, positive, decimal, fraction, whatever. You want the variable positive. You don't want your variable negative. So you want the letter to have no signs in front of it. You want it positive. The answer can be negative. It doesn't matter. You could divide by negative 3. You would get negative k equals 1, and then you would have to multiply by negative 1 to get k equals 1. Never leave your variable negative. And what I mean by that is if I would have divided by negative 3 right here, and divide by negative 3, and I get negative k equals 1, do not leave your variable negative. You want the variable positive. The solution or the answer, it doesn't matter what it is. It can be positive, negative, whatever. That's unimportant. This has to be positive. Yes? It matters because when I go to substitute it up here, this is k. This is not negative k. So I would have to reverse everything in my head, would make it really, really difficult. Okay? Because if I just say, oh, it's negative k, I don't care, I'm going to put a 1 up here. If I do this check with a 1 up here, it will not check out because it'll be 3 plus 24. Well, no, negative k. That's not a negative k, so I'd have to make it negative. I would have 3 minus 1 plus 24 would not work. Okay? Okay, I want you to try this problem as well. 15 equals negative 3 times the quantity of x minus 1 plus 9. So in this one, you'll notice we have the distributive property in addition to adding an additional 9 to it. So go ahead and solve this in your Cornell notes and then come back and check. All right, so let's walk through the solution. We have 15 equals negative 3x minus 1 plus 9. Going to apply the distributive property, which would give us parentheses negative 3 times x, minus negative 3 times 1, parentheses close, and then we keep our plus 9. Then we solve within our parentheses. We have negative 3x plus 3, and I got that plus 3 by subtracting a negative 3. When you subtract a negative 3, you add 3 plus 9. 15 equals negative 3x plus 12. Subtract 12 from both sides. I have 3 equals negative 3x. Divide both sides by negative 3. X equals negative 1. And let's go ahead and do our check. If I have x equaling negative 1, I'm going to substitute negative 1 for my x. And what I did here is I did a plus negative 1, just to make sure I was adding that negative 1. Then I have 15 equals negative 3 times negative 2 plus 9. 15 equals 6 times 9 because negative 3 times negative 2 equals 6. And I have 15 equaling 15.